Note that in this section we will not be talking about how to design a system, but we're on the lines of how to calculate numbers before we talk about designing systems. So let's look at an example. Let's say that we are building a system of the scale of Twitter. So how many users should we build a system for? Now Twitter is a service that's in the whole world, not just in one country. So let's start with there. Let's assume that some of the older and very young generation probably don't use Twitter, so we may want to discount them. We would also want to discount some of the Asian countries, especially China, where a lot of the large scale apps, including Twitter, are not really used at all. So let's simply assume that our total users are 20% of the world population. Now, this number is definitely incorrect, I assure you that. We may even be way off than the actual Twitter users, but guess what? It doesn't matter. Only thing that matters is how you approach this number and how realistic it looks. Now let's calculate our DAU. Most of the apps usually rely on their daily users rather than total users to take any design decisions. Often DAU is a very small number as compared to the total users, depending on the type of application. Let's assume that only 10% of our users are daily active. Next metric we would need to calculate is throughput. Let's say on an average, one user may query the timeline 2 times a day. So we multiply 2 with the daily active users, which would make 320 million queries per day. But our system does not need to handle queries per day, but rather than per second. Throughput is always calculated on a second level. So 320 million in unit terms would be 320 into 10 to the power of 6. Now to find queries per second, we would divide the whole number by number of hours multiplied by minutes in 1 hour multiplied by seconds in 1 minute. This will give us the queries per second. Now how to solve this equation? If you notice, we have two zeros here and here. So we can cut these two zeros with 10 to the power of 6 and come to the number 10 to the power of 4. To solve 24 multiplied by 36, we can just round off the number 24 by 20, and 36 into 20 would be 720. Now, this calculation does not at all need to be accurate. We need to save time for an interview and we just need an approximate number. So 720 plus some number, we can just round it off to 1000. 1000 would be 10 to the power of 3. So 10 to the power of 4 divided by 10 to the power of 3 would be simply 10. So we are looking at 3200 requests per second, which would be 3.2k queries per second. As you noticed, this number is not at all accurate with this calculation, but as I said, it doesn't need to be accurate, it just needs to be approximate. Now, if you notice here, there would be some days when daily active users would spike up. Let's say there is a really viral trend going on Twitter, or a hashtag is getting really popular, so our daily active users could definitely spike up. Now the spike up number could be anything like multiplied by 2, 3, 5, but 5 is something I feel quite comfortable with, and designing a system with 5 times scale would be a really scalable system. So 3.2k requests multiplied by 5, and we would have to handle around 16k queries per second. The other important part is storage analysis to help us understand how much space do we need to design this system for. So let's assume on an average each user posts one post each day with average of 100 characters per post. So let's say we want to build our storage for next 5 years. So we are looking at a storage of 116 million, which were our daily active users, multiplied by characters per post, multiplied by 5 years, which would be 365 into 5. This would come off around 32 into 10 to the power of 12. And if you remember our conversions table, this would make up to 32 petabytes. Another thing we can estimate is latency. Let's say we want 99% of requests to be processed under like 200 milliseconds. Now we don't need to tell about the exact ways to achieve that, but we can just suggest that we would want to optimize the network latency, disk read, memory read, and other metrics. In fact, our entire system design is mainly focused around reducing latency. Then we can talk about gap theorem a bit to decide between availability and consistency. For a system like Twitter, where people are online all the time, we would want the system itself to be online most of the time. So we should aim for availability rather than consistency. So this was just one quick lesson on how to estimate numbers. In the case studies later on in this course, we'll deep dive more into this and how to follow up after you have made these estimations.